solving rational equations. This section, the past few sections were covered to lead up to this section. Solving rational expressions. Do some simple ones first. Suppose you were told that 18 divided by 3b is equal to negative 6 over 2. I would simplify first. 3 goes into 18 always 6 times. It isn't like sometimes it's not 6, it's always 6. So 6 divided by b is equal to, now, I was ready to say that this is negative 3, but you know what? Instead of negative 6 over 2, this is the same as 6 over negative 2. I mean, they both have 6 over 2, so that's not changing. And a negative over a positive, which is a negative, is the same as a positive over negative. This is 6 over negative 2. If two fractions are equal and the tops are equal, well, then I know the bottoms are equal. D is negative 2. E is negative 2. Suppose you have 4x plus 5, and you divide this by 6, and this is said to equal to 7 over 2. Well, you can simplify the left side, you can simplify the right side. Now, I want to know what the LCD, better known as the LCM, for 6 and 2 are. And you can play the same game that I've been doing. 6 can be written down in prime factor form as 3 times 2. So in the left-hand corner, I need a 3 and a 2. And 2 is already factored. I need a 2, which I already have. The LCD is 6. The LCD is 6. So I'm going to multiply both sides by 6. At least I'm going to denote that. I'm going to denote that I'm multiplying both sides by 6. And on the left side, the 6's cancel. You get 4x plus 5. On the right-hand side, 2 goes in there. 6 3 times. You get 7 times 3, which is 21. Some number, when you add 5, gives you 21. The number 16. If you really didn't know it, here is some number right here. Add 5. 1, 2, 3, 4, 5. And get 21. 20, 19, 18, 17. That unknown number, which we called 4x, is 16. 4 times some number is 16. 4. Okay. Now, a lot of you, not all of you, were taught to divide by 4, which works. But 16 divided by 4 is not nearly as simple question as 4 times what is 16. You memorize your times table. Most of you didn't memorize division tables. Personally, I've never seen a division table. To solve these rational equations, we multiply by the LCD. You have x minus 1 over x minus 5, and you add, well, you want it to actually equal, I guess. You want this to equal to 4 over x minus 5. Well, the LCD is x minus 5. So I take each of these fractions, and I denote that I'm multiplying both sides by x minus 5. Now, this cancels out, provided it cancels out to 1, provided x is not 5. Well, x minus 1 times 1 is x minus 1. And this cancels out, provided x is not 5. Cancels out to 1, and 4 times 1 is 4. And you all know what goes in that box. It's 5. X equals 5. But we can't allow x equals to 5. So we reject this answer, and since it was the only answer, there's no solution. Now let's even try to check it. You may say, what do you mean x is not 5? Sure it is. 5 minus 1 is 4 over 5 minus 5 is 0. I agree you get the same on the other side, but no, they're not equal. If you don't put 4 over 0, we don't know what it equals. And 4 over 0, we don't know what it is. You can't say, well, the left and right side you both don't know. Or they both look exactly the same. No, you can't divide by 0. You can't. Even though you're getting 4 over 0 equals 4 over 0. It doesn't work. There's no solution. 4 over 0 does not equal 4 over 0. What does 4 over 0 equal? It's indeterminate. There's a case where there is no solution. Let's look at another one. Sometimes you get no solution. Sometimes you get one solution. Is it possible that you get more than one solution? Okay, between 3, 4, and 12, the first common multiple is 12. So I'm going to denote, initially at least, that I'm multiplying everything by 12. 3 goes into 12 4 times. 4 times x is 4x. I'm taking 12 because all of the denominators go into it. 3 times. 3 times 3x is 9x. Equals. It'd be more interesting to make this negative 12x. Negative 5x. It'd be more interesting if the original problem had negative 5x over 12. Okay, and 12 goes into 12 one time. Anything times 1 is anything. Now, the left-hand side is negative 5x. And the right-hand side is negative 5x. No matter what number you use, the left side equals the right side. That is all real numbers. That's the solution. If you just look at x over 3 minus 3x over 4, if I multiply this by 4 over 4, which is 1, I'm allowed to do that, and I multiply this by 3 over 3, well, I get 4x over 12 minus 9x over 12, which is negative 5x over 12, which is exactly what the right-hand side was. I mean, if somebody says, what's the answer to this? You should say, oh, x can be any number. Because no matter what number you pick, 3 times that number equals 3 times that number. So it's called an identity. Any x will work. W minus 3 plus 1 over W plus 3 this is equal to negative 5 over W squared minus 9. So we want to multiply by the LCD. This W minus 3 cannot be factored any further. Same with this. but 9 is the same as 3 squared. So you have w squared minus 3 squared. W and 3 are being squared with a minus in the middle of them. So you can factor that. So let's find out the least common multiple. I need to write this down. I haven't yet, so I do so. I need to write this down. I haven't so I do so. I need to write down w minus 3. I already did. I need to write down w plus 3. I already did. And there it is. That's your LCD, which is the same as this. Alright, so now I need to get all 3 fractions that have the same denominator, namely what's in the bottom. For the first fraction, I multiply top and bottom by w plus 3. The second fraction, I have the w plus 3, I need the w minus 3. In fact, I want to get rid of the denominators. I'm going to multiply everything by this. I'm going to take 1 over w minus 3, and I'm going to multiply it by w minus 3 times w plus 3 plus 1 over w plus 3. I'm going to multiply it by w minus 3, w plus 3 equals, I'm going to take this, and I'm going to multiply it by what I've been multiplying the others by. Except I'm just going to write it differently. I'm going to write it down as w squared minus 9. That way, it's easily seen that they cancel out to 1. Alright. This cancels out to 1, provided w is not 3. So I get 1 times 1 times w plus 3, which is w plus 3, plus. This cancels out, provided w is not negative 3. Cancels out to 1. 1 times w minus 3 is w minus 3 times 1 is still w minus 3. Equals, as long as that w is not 3 or negative 3, this division is 1. Negative 5 times 1 is negative 5. And the 2 restrictions I just said for the last division, I already listed. I will not allow those to be the answers. Okay, so w plus w is 2w. 3 plus negative 3 is 0. So 2w plus 0 is 2w. This equals negative 5. Divide by 2, and the only possible answer is negative 5 over 2. And since it's neither of these numbers over here, here's my answer. Okay, there's the answer. Suppose you have this problem. Back to the bottom here, you get 2 times y plus 1. 4 times y plus 1. Y plus 1. The numbers are hard. We have to think and do stuff. The first common multiple between 2 and 4 is 4. Okay. I need to write down y minus 1. I need to have y minus 1, and I do. Down in the corner, I need y, I'm going to say y plus 1. I need y plus 1 down in the corner. I already have it. So this here is my least common multiple. So I take the first fraction. Actually, in fact, this form is best. And I denote that I'm multiplying it by 4 times y plus 1. Plus, I take the second fraction, 2y minus 16 over 4 times y plus 1. And I denote that I'm multiplying it by 4 times y plus 1 equals, I take that third fraction, and I denote that I'm multiplying it by 4 times y plus 1. And this should, if I didn't make the wrong choice of common denominator, this should kill off all the denominators. This cancels, provided to 1, provided y is not negative 1. And 2 goes into 4 2 times. Y times 2, 2y. Plus, the 4's cancel and to 1, and this cancels to 1, provided y is not negative 1. I already have that. So I add on 2y minus 16 equals, this cancels out provided y is not negative 1, and you get 8y minus 12. Okay, 2y plus 2y is 4y plus negative 16 is the same as taking away 16, and this equals, is that an 8? Excuse me, 8y minus 12. You bring these to the right side, and you'll have 4y left. 8y minus 4y is 4y. You bring the negative 12 to the right side, it's positive 12. Negative 16 plus 12 is negative 4. 4 times some number is negative 4. This tells you that y is negative 1. But that's exactly the value for y we must reject. We reject. So no solution. Sometimes you may get 2 solutions and keep both of them, or maybe you'll just have to reject one of them. If you reject one, you keep the other. Or you reject both of them and you have no answer, no solution. Here's the case where you had no solution. Let me do one more of these. It's really not common or uncommon to get no solution. The nice thing about writing down on the side where y can't be is the only other alternative is to get your possible answers, like the last one we got. I think it was negative 1, plugging it back into the problem and seeing if it works. That's a 9. Now, these problems are coming from a classroom setting. And they're designed to work out nicely. Now, you can't factor w minus 5 any further. You can't factor 2w plus 1. But you can possibly factor this quadratic. And I wouldn't be shocked if w minus 5 wasn't a factor. In fact, I would not be shocked if the other factor was 2w minus 1, 2w plus 1. So even if you're not good at factoring, you can just take a guess. That multiplies out to 2w squared plus 1w minus 10. If you add 1 and take away 10, you're 9 behind. Minus 5. And that's exactly what we have here, so I know that's true. Okay, so hw minus 5, 2w plus 1. They're designed to work out smoothly. I want you to have that talent, which is in a way a non-talent. That is, you don't even have to have the talent of knowing how to factor. Okay, LCM. I have to have that down in the corner. I don't, so I write it down. I need to have w minus 5 in the corner. I do. There it is. I need 2w plus 1 in the corner. I don't have it yet. Just put it down. And lastly, I need 2w plus 1 in the corner, and I have it. Keep in mind that this is 2w squared minus 9w minus 5. So I take each of the fractions, and I denote that I'm multiplying it by what's in the bottom corner. Either I'm going to write this, or I'm going to write that. They are equal. In this case, I'm going to write it down as w minus 5 times 2w plus 1. That way, I can easily see that canceling. Equals 22 over 2w squared minus 9w minus 5. In this case, I'm going to write down 2w squared minus 9w minus 5. Because then I can easily see that canceling. And for the last one, I'm going to write w minus 5 times 2w plus 1. Now, I said that these two cancel out to 1, provided w is not 5. So, I have 2 times 2w, 2 times positive 1 is positive 2, equals. Now, remember, this was really w minus 5, 2w plus 1. W minus 5, 2w plus 1. The w minus 5's cancel out to 1, provided w is not 5. I already have that. This cancels out to 1, provided that 2w plus 1 is not 0. That is, 2w is not negative 1. Divide by 2, w cannot be negative a half. Okay. So this is 1. 22 times 1 is 22. Minus. The 2 w's plus 1 cancel out, provided w is not negative a half. But I already have that. So I take away 3w. And because negative 3 times w is negative 3w. Negative 3 times negative 5 is plus 15. And that's the equation that I'm going to solve. And I will reject any answer that suggests that w is 5 or negative a half. Okay, let's clean up both sides. The left side is simply 4w plus 2. The right side we can simplify. 22 plus 15, 37, minus 3w. And bring all the w's to the left side. And I'm going to take away 2, bring all the numbers to the right side. So I have 7w is 35. 7 times some number is 35. That means the number is 5. But that's one of the numbers I have to reject. Reject, which means no solution. Okay, that finishes up this section on solving rational equations.